This is the last video from chapter 2. Okay, this is similar to the linear equation that linear first order ODE that we solved, but it is a little bit different. So we can substitute something and then get the linear form. Okay, let me first define what is Bernoulli's equation. Okay, so a differential equation of the form dy over dt plus pt times y. We saw that left hand side already, but on the right hand side, if there is just qt, not y to the n, just qt, then it is called linear. But you will see some equation on the right hand side, you will get qt times y to the n. Okay, you will see dy over dt plus pt times y equals to qt times y to the n. So this type of equation is called Bernoulli equation. That n can be any integer or negative numbers or any real number, decimal, fraction, anything. Okay, so if n is equals to 0, if n is 0, then y to the 0 will be 1. So this will become linear equation. Okay, now to solve Bernoulli equation of this form, we divide both sides by y to the n. We divide both sides. So you divide this by y to the n, this by y to the n, and then this by y to the n. What do you get? You will get 1 over y to the n times dy over dt, and there is y over y to the n, right? What happens? It goes to the top, there is y to the 1, and then it goes to top by negative n. So y to the 1 minus n times pt equals to that yn will cancel out, so it will be qt, right? Now what we do next is you set this guy equals to, so you set this guy equals to u. We are trying to change this into a linear form. Okay, u equals to y to the 1 minus n. Then what happens? Find out the derivative of this. We are trying to find out the derivative with respect to t or with respect to x. You can do if it is a function of x like that. So du over dt equals to, it is like power rule, right? 1 minus n. This what is the derivative formula? So so y to the n over dt will be n y n minus 1 times, and then times dy over dt, right? Dy over dt, that's what you do, right? So similarly here, what we are doing, n y n minus 1 times dy over dt. Okay, so what happens here is you cancel that 1 and 1. Okay, what happens is 1 minus n, and then y to the negative n means 1 over y to the n times dy over dt. So you can write this equation, that star equation, as, so what is the value of this? Implies that if you divide both sides by 1 over 1 minus n, then you will, what do you get? du over dt. So 1 over n minus 1. So divide by 1 minus n. So you cancel out that. So you'll get 1 over n minus 1 du over dt is equals to 1 over y to the n times dy over dt. So this guy is basically 1 over n minus 1 times du over dt. That's what I wrote. Plus pt times, we set that as u, right? So that is u equals to qt, because that is cancelled out after you divide by y to the n. Now look at this. I multiply both sides by 1 minus n. What do I get? du over dt plus 1 minus n times pt times u equals to 1 minus n times qt. Okay, so this is linear in ut, because see, du over dt, some function times u, derivative of u, some function times u equals to some function of t, because n is a number here. Okay, so this is linear in ut. So to solve this, what we do is we use the linear method. We find out the integrating factor, multiply both sides, and write the left hand side as the derivative of u times the integrating factor. That's what you do. Okay, so let us do this example, it will be clear. Okay guys, so let us simplify this and write in the Bernoulli standard form. What do you get? You get dy over dt plus, you get ty to the equals to ty to the 4, so equals to ty to the 4 minus y, right? But Bernoulli needs y and the derivative on the left side, so you can write dy over dt minus, so plus y equals to ty to the 4, which is in the Bernoulli form, right? Bernoulli, N-O-U-L-L-I, Bernoulli form. So to solve the Bernoulli form, what do? You divide by y to the n. So see, here is qt, is that t is qt. Now this is y to the n. So divide both sides by y to the 4th. What do you get? 1 over y to the 4th times dy over dt, right? Plus y over y to the 4th will be 1 over y to the cubed, right? Time. So 1 over y to the cube equals to just t equals to t. So what you do is this y to the some exponent, that should be what? That should be u, right? Let's move that to the top. U equals to y to the negative 3, right? So what will be du over dt then? Du over dt will be negative 3 y to the negative 3 minus 1 times dy over dt. So divide both sides by negative 3. So negative 1/3 du over dt equals to y to the negative 4 dy over dt. See, so you can write, oh, by the way, I forgot to divide this by, oh yeah, there you go. So this is the one, right? So this thing can be written as negative 1/3 du over dt. This thing is just u, right, equals to t. So that's what you can write. So star, let's say this equation is star becomes negative 1/3 du over dt, right? And then plus u equals to what? T. That's what you get, right? Now multiply by negative 3. What do you get? Du over dt, right? Plus minus 3u. Minus 3u equals to minus 3t. That's what you get. Okay, guys? So this is what you get here. So what I'm doing next is I'm trying to find out the integrating factor. So how do I find out the integrating factor then? So the integrating factor is p, because this is linear in u. So p equals to e to the integral negative 3 and then dt. So that is e to the negative 3t, right? Multiply both sides by e to the negative 3t. What do you get? So you are multiplying this by e to the negative 3t, this by e to the negative 3t, and then this by e to the negative 3t, right? So what do you get? You get, after you multiply by the integrating factor, the left hand side will be solely the derivative of the integrating factor e to the negative 3t times the u. That's what you get. And in the right hand side, you got negative 3t times e to the negative 3t. Now you integrate on both sides, okay? Let us integrate. So integrate on both sides. So this is like with respect to dt, right? So this is with respect to dt. So that derivative and the integral will cancel out. So what you get on the left side is e to the negative 3t times u equals to integral negative 3. Let's put negative 3 outside. And then t times e to the negative 3t dt. So you need to do the integration by parts, right? So do you remember how do you do integration by parts? You can write u and dv, and you can find out the derivative of u and integral of dv, right? So that's what you do. So let me, okay. So what you get there is basically, you will get e to the negative 3t times u equals to, let me find out u and then dv. U is t, dv is e to the negative 3t, right? What do you get? The derivative of u is 1. Integral of this is e to the negative 3t over negative 3. This is 0. This is e to the negative 3t over negative 9, right? Because why? E to the negative 3t will be e to, at. Let's say at formula. E to the negative at over a. That's the integral formula. So what do you get? This is the positive multiplication. This is a negative multiplication. Okay, what do you get there? Is negative 3 times t e to the negative 3t over negative 3, right? And then minus, that will be plus because there is minus 9 and then this is minus multiplication. That will be plus e to the negative 3t over 9. That's what you get. Okay, guys. So what do you get here? Is let us distribute that. E to the negative 3t times u equals to t times e to the negative 3t, and negative 3 times that negative 3 will cancel out. Negative 3 times that will be minus e to the negative 3t over 3, and then plus c. Oh, I forgot plus c here. So we need plus c. Now divide by e to the negative 3t. What do you get? E to the, so therefore ut equals to divide by that. E to the negative 3t, e to the negative 3t, e to the negative 3t, and then e to the negative 3t. So that will cancel out. So what is left is basically you will get t minus 1/3 plus c e to the negative 3t. That's what you get. Okay, guys. So this is the final answer you get. ut equals to that thing. So this is how you solve the Bernoulli equation. Okay. So I want to do one more example here. Okay, let us do one more example. It is a question number, let me see. It is question number 19 from the book. Okay, this previous problem was question number 14. The problem I just did was question number 14. And I want to do question number 19, that is example. So you can see basically the direction field of each of these problems by solving for dy over dt equals to write everything on the right hand side and then enter that into that software, into that app that I showed you in the last classes. Okay, so solve, it says dy over dt equals to y plus root y. So this is not in the standard Bernoulli form. Okay, so let me write down the solution. First of all, I want to write this in the Bernoulli form. So solution, to write in the Bernoulli form, that y should be on the left side, so you write dy over dt plus y equals to root under y, right? See that pt times y equals to qt times y to the sum power. So I want to divide both sides by this, right? So what do I get is 1 over y to the 1/2, because root y is that one. Okay, dy over dt plus y over root y will be y to the positive 1/2 there, right? Because y over root y equals to just 1. Okay, guys. So so what do you need to substitute for u? That thing will be u, right? If there is a function of t, just y to that power will be u. Okay, so set u equals to y to the 1/2. Suppose there was like 5 y to the 1/2. You just keep 5 and then that is always u. If there is like t square times y to the 1/2, the t square will stay there, but y to the 1/2 will be again u. Okay, now find out the derivative. Du over dt equals to 1/2 y to the 1/2 minus 1, right, times dy over dt. So multiply by 2 on both sides. What do you get? 2 du over dt equals to y to the negative 1/2 times dy over dt. Look at this. This is y to the negative 1/2, right? This guy is y to the negative 1/2 times dy over dt. That you can write that, replace that by 2 du over dt. So this is basically u, right? And equals to 1. So you can write that is, let's say, star can be written as what do you get? You get 2 du over dt, that plus u. Okay, is that a plus u or minus u? That is like, let me see. Oh, by the way, this must be minus, right? This must be minus. This must be minus. When you bring that to the left, this must be minus, and then that will become minus there, right? So I missed that minus sign there. Okay, so it will be minus. Okay, and then what? 2 du over dt minus u equals to 1, right? So what is the integrating factor? So this is the let me divide by 1/2 first. So du over dt minus 1/2 u equals to 1/2, which is linear in u. So what is the integrating factor then? Integrating factor will be e to the integral, that pt, right? P is negative 1/2 dt equals to what? E to the negative 1/2 t. That is the integrating factor. Okay, so what we do is we multiply this equation. Which equation? That equation, by e to the negative 1/2. So what do you get? So e to the negative 1/2 t du over dt, e to the negative 1/2 t, okay, minus e to the negative 1/2 t times u, okay, equals to e to the negative 1/2 t times 1/2. That's what you get. Now what we do, the left hand side basically is the derivative of the integrating factor times u. So you write d over dt e to the negative 1/2 t times u. That is the left hand side, and the right hand side is, let me write down the number first, e to the negative 1/2 and then t, right? So integrate on both sides. What do you get? Let us integrate here. The integration and the derivative will cancel out. You will get u times e to the negative 1/2 t equals to 1/2 e to the negative 1/2 t over negative 1/2, right? because e to the ax has the integral e to the ax over a. So that 1/2 and 1/2 will cancel out. So what is left is u plus c. Don't forget that. U times e to the negative 1/2 t equals to e to the negative 1/2 t plus c. You see that? So what do you get then? We are good so far. So let us divide by that, e to the negative 1/2 t, right? E to the negative 1/2 t and e to the negative 1/2 t. So that cancel out. So what do you get? Ut is equals to, that will cancel out, 1 plus c times e to the 1/2 t, right? 1/2 t. That is the value of ut. Oh, by the way, I forgot to write, this equation also I forgot to write in terms of y, right? In terms of y. What was the value of ut there? The value of ut on that problem was y to the negative 3. The value of u was y to the negative. So this will be y to the negative 3 equals to t minus 1/3 plus c e to the negative 3t. So what will be the final answer? You need to, this is 1 over, this y to the negative 3t is how much? It is basically 1 over y cubed, right? That's what this means, right? That's what this means. So if you want to solve for y, what you need to do is, so you need to flip-flop. So you need to put that reciprocal and that whole thing will go to the 1 over. Okay, so you can write that. So you complete that yourself, okay? Because I forgot to write in terms of y. Okay, let me do it here for this problem. So what is ut though? So ut here is y to the root, right? So root under y, you see that, is equals to 1 plus c e to the 1/2 t. Okay. Oh, by the way, minus 1, right? There is minus there, right? This minus is there. Minus. So what is y? Square on both sides. You get negative 1 plus c e to the 1/2 t to the square. That's what the final answer. Okay, let me do let me complete this one, okay, the previous problem. So that will become 1 over y cubed, that is the value of ut equals to t minus 1/3 plus c e to the negative 3t. That's what you get, right? Now what is, so flip-flop, let's do that. Y cubed is how much? 1 over t minus 1/3 c e to the negative 3t. So what is y then? So yt will be, basically take the 1/3 root, right? So you can write 1 over, you can write cube root, or you can write t minus 1/3 plus c e to the negative 3t to the 1 over 3. That's what you get. Alright guys, so this is the final answer for the previous example, and this is the final answer for this example. Alright, thank you. So this is the end of chapter 2. Okay guys.